So today we're talking about lesson 3.2, so module 3, lesson 2. And your learning goal today is to be able to make equivalent fractions by adding fractions or multiplying fractions on a number line. Okay, so there's lots of things there. Let's talk about the problem of the day first. What does it mean to be equivalent? Today our math goal is to be able to make equivalent fractions. So in order to make equivalent fractions, we need to know what it means to be equivalent. What does it mean to be equivalent? Sporty?
Equivalent means
Equal. So we just practiced with equivalent fractions. We learned that 1/2 is equivalent to, say, 2/4, which is also equivalent to 5/10, which is also equivalent to 200 400ths, right? Do you guys agree? Okay. Now, is that the only way to be equivalent, though? Could I make something equivalent by adding? For example, is 2 plus 1 equivalent to 3? Right? Is 2 plus 1 equal to 3? So is 2 plus 1 equivalent to 3? So we can make things equivalent by adding. Could we also make things equivalent by multiplying? Like 2 times 5, is that equivalent to 12?
no.
No. But is it equivalent to 10?
Yes.
Okay, so we can multiply to make things equivalent as well. Could we also subtract and divide to make things equivalent? Equivalent just means equal or the same value, okay? So today we're going to focus on how we can add or multiply things to make them equivalent, okay? And we're going to use what tool to help us today? We're going to use a number line, okay? Great. Okay, and then also draw yourself, in addition to writing 1/3 plus 1/3, also draw yourself a number line. You can see the number line goes from 0 to 1, and I split it into thirds. So here's 1/3, 2/3, and 3/3, which is another word for 1. Okay, we can also say that 0 is 0/3, right? Okay, so now we're going to use this number line to help us add 1/3 and 1/3 to see what's equivalent to that. So if I start at 0, right, because when I add, do I have anything to begin with? I start with 0/3, and I'm going to add 1/3. After I add 1/3, how many thirds do I have? 1/3. Now if I add another third, because it's 1/3 times 1/3, where am I at? 2/3. So therefore, 1/3 plus 1/3 is equivalent to how many thirds? 2/3. Okay. So another way to write that, though, we know that multiplication is the same as repeated addition, right? So do I have repeated addition here? Yes. I have how many 1/3s? 2. So I'm doing 2 copies, or 2 times 1/3 to equal 2/3. I'm going to do this new problem, 3/8 plus 3/8 plus 1/8. I drew a number line again, but this time I divided it differently. I still have 0 at the beginning and 1 at the end. But this time I want to divide it into how many equal sections?
8.
How do I know I need to divide it into 8 equal sections? Besicht? Yeah, because the denominator is 8, I'm going to divide this into 8 equal sections. I'm going to label it 0/8 over here. 1 is also 8/8. And then I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and 7/8. Okay? All right, now let's add. I'm starting from 0, because when I add, I don't have anything to begin with. And how many 8s do I need to travel first? 3/8, and that lands me at 3/8. Then how many 8s do I have to travel next?
3.
Another 3, so I'm going to count 1, 2, 3, which would land me at 6/8, right? So here's 3/8. Here's another 3/8, and then I have to add how many 8s at the end? 1 more. There's 1/8, which lands me at what number? 7/8. Therefore, 3/8 plus 3/8 plus 1/8 equals 7/8. Okay? Now, if I want to change that into multiplication, I see repeated addition, right? Is all of it repeated addition? No. I have 2 copies of 3/8, so that's why I have 2 times 3/8 in parentheses. And I'm going to add another 1/8, and so that equals 7/8. Express this fraction as the sum of 3 equal fractional parts. And then you need to rewrite it as a multiplication equation. So here we have a fraction, 6/2, and I need to write it as the sum of 3 equal fractional parts. When I'm talking about sums, am I talking about addition, subtraction, multiplication, or division? Addition. So I'm trying to have something plus something plus something equals 6 halves. Okay, so what I did was I drew a number line here. And I started with 0 because I always start with 0. And then I ended up with 6 halves because I know that that's what I wanted to have it be. Okay, and I need to split it into 3 equal groups. Okay, so I did 1 half here, 2 halves here, 3 halves here, 4 halves here, and then 5 halves. Okay, so how many sections do I have all together? Let's count them. 1, 2, 3, 4, 5, 6. I have 6 sections all together, and I'm trying to split it into how many equal parts? 3. So 6 divided by 3 is 2. So I can split it into here's one part, here's another part, and here's a third part. Do I have 3 equal parts? And how big is each part? From here to here, how big is this part? 2 halves. How big is this part here? 2 halves. And how big is this part here? So this is equal to 2 halves plus 2 halves plus 2 halves. Did I do what the problem asked? Did I split this fraction, 6 halves, into the sum of 3 equal fractional parts? Yeah. Okay. Then I need to rewrite the fraction as a multiplication equation. So if I have 2 halves plus 2 halves plus 2 halves, how can I write that as a multiplication equation? Junebuk?
3 times 2.
Equals 3 times 2 halves. Okay, you don't really need the parentheses, but putting them there won't hurt either. Express the fraction as a sum of a whole number and a fraction. First of all, how do we say this fraction right here in word form? How do we say this in word form? Sophia? 8/5. Is 8/5 going to be greater than 1 or less than 1? How do you know that 8/5 is going to be greater than 1? Arun?
We can see that 8 is greater than the 5.
Yeah. How many fifths would equal 1?
5/5.
5/5. So 8/5 has to be greater than 1. Okay? So we're trying to express this fraction of 8/5 as a fraction of a whole number, sum of a whole number, and a fraction. So we know that, let's draw a number line. Let's go from 0/5, and then let's mark off 5/5 and 10/5. We know that 0/5 is really 0, 5/5 is really 1, and 10/5 is really what? 2. Okay? And here we have, I split each section into fifths, right? Because that's our denominator. Now, where would 8/5 be on this number line? When we look at the number line, we can think of 8/5 as being 5/5 plus 3/5. Let's go back and reread the problem. Did we express the fraction as a sum of a whole number and a fraction? Yep. Okay, so when you see that instruction, this is what it's asking you to do.